first off, we are. Hi, my name is Daniel, and the first thing we're going to talk about is solving equations with squares. So first off, we get something simple like basic equation solving is just inverting things. Ideally, you'd be at that, but if you go to sportsandmedia.tech and check on our other lessons within mathematics and follow along, we'll do some other stuff with primary equations. But the basic equation with a square would be like x squared equals 25. This is really quite a pretty easy one because most people know that 5 times 5 is 25. But it also highlights the one thing. So algebraically, we're following our sort of methodology. We go by inverse operations, which is undoing things. And inverse pretty much should just sort of cancel out the power. Now, this x is being squared, so x times x is 25, right? So you got x times x is 25. That is true. Now we take the square root of a square, and this is a math thing, or equation, so we have to do it on both sides. So we've got the square root of x squared, which turns out to be x, and the square root of 25, which we learned early on is 5. That's not a difficult one. But wait, there's more. Because 5 times 5 is 25, correct? But so is negative 5. And there's the big, so negative times a negative is a positive. And so when we take the square root, we do need to remember this part. All geometric problems only really want the positive one, so it wasn't that big of a deal when they were first initially solving these questions. Al-Khwarizmi, I can never get his name right. It's sort of the progenitor of much of algebra. It was more of a geometric problem, and if you go look at the way we're approaching it, you can see how he approached the problem and follow through on yourself, because it's a major milestone in mathematical learning. There's no way around it. Anyway, so we know that a positive times a positive gives us 25, and a negative 5 times a negative 5 gives us 25. So we know when we take the square root, it's actually 5 and negative 5. Math people being kind of lazy at times, or shortcuts, or efficient, they're going to put this here. So when you take the square root, as soon as you take the square root on both sides, not on this side, but on the other side, we do the plus or minus the square root of 25. Right when you take it, you write it then. Now, we know 25 simplifies down, or the square root of 25 simplifies down to 5, so that works. So actually it's plus or minus 5. Adding that plus or minus addresses that problem. In the actual problem that you're solving, it may not be both plus and minus if it's asking for like distances and things, but the algebra can come up with what's called extraneous solutions, but there are solutions for the numbers. We're working just with the properties of numbers here, so these solutions come around. And in the world of like theoretical, more idealized math on the graphs and stuff, then it really shows up to make sense. So that's not too hard. That's pretty easy. So our quadratics aren't causing a problem. We're gonna try different colors and see which ones work out best. They're all the same. Thought I had a blue, but not here. Somewhere. I'll find it. We'll stick with purple, yellow, and green. Next up, a pretty common issue though, is if you have so first off, you might have x squared minus 16 equals 0, right? There's actually a couple different ways to solve it, but the traditional way of solving equations, we've got this one instance of x. Then it's pretty easy. We can just sort of inverse our order of operations and our operations and get through it. So we square it first and then subtract 16. So to solve it, we're going to add 16 and then take the square root, right? So x squared equals 16. We take the square root. Now that undoes this side. But over here, remember we got to do our plus and our minus. The square root of 16 happens to be 4. Boom. Easy. What happens if that 16 turns into a weird number? Like 20. We still add the 20. We still take the square root if we're doing it all the way through. And at this point, we've got kind of an issue. There are far fewer numbers that actually simplify under square root. Almost all of them don't. And then the actual answers after that are like irrational. So the square root of 20 is not an incorrect answer. That's mathematically plus or minus, obviously, because we brought it over to the square root, got our plus or minus. Fine. Anyone who tells you this is incorrect is really just kind of being persnickety about certain details. Now, if we want to simplify it, there's a couple different ways. I'll have another lesson on that. The factor tree method is the best method. I'm going to skip to the faster method. It sounds like my son is whistling in the background. I can totally hear him. And in this one, you kind of have to think in perfect squares, like 4, 9, 16, 25. 4 goes into 20, right? So 4 times 5 is 20, right? The square root of 4 is 2. And so we can pull that 2 out. So we have plus or minus 2 root 5. Not everyone can pull fast at the perfect squares like that, and it gets cubes or more complicated or uglier numbers. Sometimes you're just tired. That doesn't work. Like I said, I will make one with the factor tree method, which is really good for understanding it, among other things. So hey, we're gotten that far. Now, what about if it's like x squared plus 16 equals 0, right? We bring our 16 over. And then we take our square root, right? This is a conundrum. This negative here. Because a negative times a negative is a positive, and a positive times a positive is a positive. So there's no number, so we need some number times itself. That gives us negative 16, right? We don't have that. Mathematicians realized this thousands of years ago in different branches of mathematics. They came up with a solution for this. Other groups would be like, well, it can't be done, but it's done, and they just did it. And all they did is recognize that certain numbers have certain properties. And they came up with this idea that I is just I. It doesn't mean imaginary number, it's just I. And its property is such that I squared equals negative 1. This is the only unique property about it. Everything else about it is exactly like all the other numbers. It adds, subtracts, multiplies, about all those things. But it has this unique property, which kind of takes other things apart. So we can break this apart. Remember how we broke them apart last time, like 4 and 5 or whatever. So we can break this apart. We got our plus or minus, and you got your square root of 16, and you got your square root of negative 1. Right? 16 times negative 1 is negative 16. 16 is easy, that's just 4, right? And now we have the square root of negative 1, right? Well, we created this number, I squared equals negative 1. So if we take the square root of both sides, we find that I equals square root of negative 1, some variation. This, thinking of it like this can be tricky, thinking of it like this is a better way to remember, but it's cool, you can do either way. So this negative 1 is actually, if we're working with it, an I. And to make reading easier, we kind of put it in the front of the radical sign. Oh, that was a 4 anyway. So it goes by minus, so plus or minus 4 pi. And there we go. So now we can do it with those types of numbers. We are cooking with gas, they say. I read somewhere that you're not supposed to cook with gas anymore. It makes for the best cooking, though. Alright. And then we came along, and then that was all fine. You can do pretty much any numbers. You might have imaginary numbers, or you might have wonky numbers, but you can do all the numbers.